today our next section is going to be on the topic of polymers. So now let's understand what exactly is a polymer. So if you see, this is an ethene molecule and this has two carbon bonds, and it has 4 hydrogens over here, which are nothing but shown by white colored arrow, and if you could see the distinct double bond. Now this is a small molecule C2H4, so its atomic mass is going to be like carbon is 12, hydrogen is 1, so C2H4 is going to be 28 units. Now in this case, if you have the same molecule over here, you have one more molecule. Now see what exactly I am going to do. I am going to break one double bond and then connect it to another molecule. So it forms, now these two molecules are connected. Now I have one more. Okay, so I am breaking the double bond again and then connecting it to another molecule. So if you could observe, this has formed something like a, what do you say, a network type of structure, something like a chain in which all the atoms are connected end to end. So this is nothing but a polymer. So what exactly do you mean by polymer? A polymer is nothing but, if you observe, you could have one more chain from here, one more molecule here, so it could go on and on for something like 10, 100, 1000, 10,000. So overall the molecular weight is going to be very, very high. So how would you define a polymer now? A polymer is high molecular weight. Since this is a macromolecule, you would say a high molecular weight macromolecule in which you have small molecules are arranged in a definite manner. So there are small repeating units over here, they are connected end to end. So this is nothing but a polymer. These small molecules or these small repeating units, they are called as monomers. Okay, so this is nothing but a polymer. Now based on this polymer, you could have different structures. So this is a linear polymer, right? So now I could have something like a branch, or I could have something like a ring structure. So instead of this, I could have a carbon-carbon ring over here, right? So something like a ring structure. Now these are just things are connected end to end. I could remove this particular hydrogen atom and then I could have a ring structure. I could just put one more molecule over here, right? So this would give rise to a ring. So now these things which we are going to study in the aspect when we are going to study the classification of a polymer. So now let's know what exactly is a polymer. Polymer is nothing but a high molecular weight macromolecule in which you have small molecules of low molecular weight, or small molecular units are arranged in what you say a repeating manner. So this was about the generalized definition of a polymer. Now let's try to define. So what exactly do you mean by a polymer? Polymer is nothing but a high molecular weight macromolecule . Now this high molecular weight macromolecule is obtained by joining smaller units of low, you could simply say molar masses. So now this process of formation of a polymer is called as, so this process is called as polymerization. Okay, and then you have these small units, they are called as monomers. Now let's have a brief account of polymers classification. So now let's study the classification of polymers. So before the classification, let's have some general examples about the polymer. So you could simply write the polymer like polythene, the polythene bags which we generally use, the Bisleri bottles which we have, they contain something like polypropylene, And then you have something like nylon, again that's a polymer, nylon cloths. And then you have silk is again a polymer. And then you have something like terylene, right? So you even have something like cellulose, which is nothing but a natural polymer. So now let's try and understand the classification of polymer. So the first system of classification, first method of classification is going to be based on sources. So when we talk about sources, three aspects come to our mind. So generally it is two, but third is in between first and second. So the first is natural, polymers obtained from nature, and then you have synthetic. So this classification is on the based on sources. On the basis of sources, you have natural, you have synthetic. So you call this as semi-synthetic. So natural polymers, they are the polymers which are obtained from nature. Example is cellulose is a polymer. Then you have silk is a polymer which is obtained from silkworm. Then you have synthetic polymer. Synthetic polymers, they are basically lab made. You could say that they are man made. Okay. Then you have example, common example of synthetic polymer is you have polythene, you have polypropylene, and you have all other synthetic polymer. Now in the case of semi-synthetic, what exactly they do is they modify the properties of a natural polymer. Okay, so common example of this is cellulose rayon, then you have viscose rayon, then you have cuprammonium silk. Cuprammonium silk. So these are the examples of classification when we do it in terms of sources. Now depending upon let's say when we are talking about the units, so when depending upon monomers, the next type of classification is going to be. So now when the monomers, they are of same type, when the monomers are same and the monomers are different. Okay. So now when the monomers are same, you call it as homopolymer. Okay. For example, if you have a monomer A, right, n molecules of A react, so it forms a chain like this and so on. So this is called as homopolymer. Common example here is polythene. Polythene, polypropylene, you have Teflon, you have PAN, that is polyacrylonitrile. When the monomers are different, you call it as copolymer. For example, you have a monomer A, you start with n molecules of A, then you start with n molecules of B, you get n, you could simply say that n such of A, B. So you could simply write this as AB n times. Okay, so this is nothing but a copolymer. Common examples are nylon 6,6, then you have terylene, and many more which we will be studying in detail. Now the third method of classification is going to be depending on the reaction, type of reaction. You could say the preparation method. So now the preparation method, when the reaction, when it is addition reaction, you call it as addition polymerization, and when you have a condensation reaction, you call it as condensation polymerization. For example, in the case of addition, you have a double bond. Let's say if you take n molecules, so it forms a polymer like this. Okay, and when you have a condensation, let's say if you have a monomer that has COOH, and if you have another monomer that has OH, so H and OH will react to form water, so the resultant polymer is going to be something like an ester. Okay, so this is nothing but a polyester. Okay, so this is one method of classification. We have other methods of classification as well. So now what could be the other method of classification? See, the other method of classification could be something what we would say that it is dependent on the strength. Okay, so depending upon the strength, it is classified into 4 to 5 types. So the first is fiber. So many of us know that fiber is nothing but material in the form of thin filament which can be woven into a fabric, right? So it is nothing but thread-like. For example, you have silk threads, you have nylon threads and all. Then you have something which is like elastic. So you have elastomer. Example, this is rubber. Most of us know that what do you mean by elastic in nature? When you just apply force, it stretches, and when you just release the force, it comes back to the original position. This is true only when it is in the elastic limit. So example is rubber. We'll be studying this in detail as well. Then you have the third category, that is thermoplastic. What do you mean by thermoplastic? Thermo means it is related to heat, high temperature, and plastic. So now you might have seen that when you just melt a plastic, it becomes a liquid. When you just cool it, it solidifies. So thermoplastic, they are the polymers which melt on heating and solidify on cooling. So it solidifies on cooling, and you could keep on doing the same process again and again. So I would simply say they can be remolded again and again. Example is the plastics which are generally used. Okay, then you have the next classification which I am writing it on the other side. So it is exactly opposite of thermoplastic. So you call it as thermosetting. So what do you mean by thermosetting? So they cannot be remolded. They cannot be molded again and again. So what exactly are thermosetting polymers? Thermosetting polymers, they are nothing but, you could say that they permanently set. When you heat it, nothing would happen. So common example of a thermoplastic polymer we have studied. Any thermosetting polymer, you could just give an example as bakelite, which is used in electrical switches and fuses, and you have melamine, which is used in crockeries. So this was the method of classification of polymer based on sources, based on the monomers, whether they are same or different, and based on the preparation method, as well as based on the strength. Based on the strength, you classify them as thermosetting, fiber, elastomer, thermoplastic, and thermosetting. So this was about the classification. We may have few more methods of classification, but these are the most important ones. Now we studied about 4 methods of classification, and I didn't discuss the 5th one because of a particular objective. So the 5th one is going to be something which you have to keep in mind, and these are the things which you should just keep in mind that will help you in understanding the application of particular polymer. So now the final mode of classification is based on something what you call it as the nature of the chain, right? So the last method of classification, so this is something which we are going to discuss on the basis of something what you call it as structure. Okay. So I have shown a polymer which was something like this, the chains connected together. So you call it as linear. So when they are connected in straight line, then you have branched. What do you mean by branched? Let's say if you have one polymer chain like this, you could have another chain like this, and you have the growing part. So this is forming branching, right? So it is called as branched polymer. Now in between the linear and branched, we are going to have something which is a combination of linear and branch. This is one chain, this is another chain, and these chains are connected, right? So these chains are connected. You call such polymers as cross-linking polymers. Okay. So if you observe, these cross-linking polymers are cross-linked in such a way that the strength becomes more. So common example of linear polymer is polythene. Okay, a common example of linear polymer is polythene, and the branched polymer common example is polypropylene. Okay, and then when you have a cross-linking, it could be something like bakelite network polymer. If you see, there could be multiple layers like this which could form a network. So it is bakelite. Then you can also say that urea formaldehyde. So let's keep that aside. Just take one example like bakelite. Okay. So now this was basically the classification of polymer. Now let's try and understand different types of polymers which we will be studying in due course of time. So now let's start with the first category. Okay, the first category is addition polymers. So what do you mean by addition polymers? So we will be studying addition polymers as well as condensation polymers in details, and then we will also be studying something like synthetic rubber, and then we'll be studying about biodegradable polymers as well. That could be the last part of our discussion. So now what do you mean by addition polymers? So addition polymers, as the name suggests, they are formed due to addition reaction. And most of us know that addition reactions are those reactions of the type 1 + 1 = 2. That means there could be something like many reactants which it will give a single product. So that means addition reaction. So for addition reaction, there should be multiple bonds. Okay. So in general, I would say that the compound should be something what you call it as unsaturated. Okay, so this is something what you call it as unsaturated. For example, you have ethene, CH2, double bond CH2, and such molecules. And there is a way in which you are supposed to write a polymer. First, you write N such molecules and then write the repeating unit, CH2, CH2, but with a single bond. So now what exactly happened? This bond breaks and you form a chain from the one side, the other side, then you put this as the repeating. You could label this as the repeating unit. Okay. Now let's draw the original polymer. So I would draw the original polymer like this, CH2, CH2, and then N times. So this is nothing but polyethene, or you could simply call it as polythene, right? We are going to discuss many other polymers like this. So then the next is condensation polymer. So condensation polymers, they are the polymers obtained due to condensation reaction. So now what exactly do you mean by condensation reaction? Condensation reactions, they are those reactions in which small molecules or low molar mass molecules like water, it could be something like alcohol, or it could be something like an acid, like inorganic acid like HCl, HBr, HI is eliminated from the molecule. So this is nothing but condensation reaction. So common example is now let's say if you have something like RC double bond O OH, where R is nothing but a big chain, plus if you have something like let me write an alcohol molecule HO, I would simply write this as R dash. Okay, so this is nothing but a condensation reaction in which water molecule is eliminated, right? So you get R C double bond O O R. Now instead of alcohol, if you have an acid chloride, okay, so if you have an acid chloride, so you have the elimination of water molecule over here. If you have an acid chloride, then you could simply say that this gives an ester and it gives HCl, right? Whereas if you have something like what do you say, if you have something like an amide, RCO, you have OH. Now in this case I'm using something like an amine, NH2R. So in this case I'm getting a amide linkage, RC double bond O NH plus H2, right? So this is nothing but condensation reaction. We'll be studying in detail, in depth about the different types of polymers which are obtained from condensation and addition reactions.